Well, hey YouTube, it's Petey Two Finger, and the air conditioning is on. I apologize for that. So, if you follow along here, you know I had built this thing. It's a little MP3 amplifier, and I had installed a signal generator board in it, and there is a 9-volt battery with a test probe clips, and then another amplifier input. And so this device, when I finish, usually it's buttoned up and there isn't circuits hanging out of it, but when I would finish soldering up a guitar pedal, like as soon as I'm done putting the controls, the potentiometers, the volume controls on it, you're basically done with that electronic part and you can test it. So normally this would entail you soldering up some jacks and a power supply and getting cables and an amplifier. Many of us have like a Beavis board, or you'll have a different like ways, your own little cut jacks that have alligator clips on them. This is what I came up with, and so it's an amplifier, and it has a test tone oscillator. So now it's not working. Maybe it's, wow, it's not working, Gatti. No, I took it out of the. Whoa. That was me playing with the. That's a lot louder now. Maybe it would work now. See, the problem that I ran into with this is, and you know what, mate? I don't know if I want to gut this or build another one. What my plan is, I have a smaller speaker chassis. This one here. This is a Sony, like mini system speaker. Anyway, my idea was to use a battery pack running through a step down to get 9. Have the 9 volts come out of this port here. So when you finish, you plop your circuit down on top of this plastic. There would be 2 more of these types of spring-loaded wire fittings. One for your audio input of your circuit, and then one over here for the output. So you would just slap the circuit down on top of it, plug your wires for your output in here, plug the input in here, plug the 9-volt back around into this, turn the volume up, and it would beep, it would play through your circuit, and you could then determine, like playing around with the pots or whatever it is you need to do. Then there would be a toggle switch with a 1/4-inch port that would route your guitar through that 1/4-inch port out to the spring terminals. So you could select, okay, the initial test mode is through the oscillator. Beep, are we getting beep beep? And then once you've got beep beep and you know that your knobs are connected properly. See, a lot of times it's either me getting confused or the guy who did the Vero layout not giving a shit to properly label how you connect the potentiometer to the wiring. Because they won't draw it out, or they won't, it's just not listed. It's just like you're just supposed to figure out which way you want the pot to spin. Because if it is inverted, what will happen, you'll go to turn it up. I'm going to crank it up, and you'll turn it all the way down. So it's very quickly that you realize, but there's no way of knowing it until you've got the circuit fired up and running, and that's one of the reasons I run a test oscillator, is because it's easier than hooking your guitar up and having to keep hit the strings while you're playing with the controls, you know what I mean? So ultimately, for me, what my needs dictate is the first test mode is a test oscillator. The second test mode, I can plug my guitar into it. And for that, you really want a decent quality, amplifier. This isn't great. I think this speaker weighs a lot. This is like a pound. Whereas this thing, the speaker that's in here, oh, it's not bad. 4 ohm, 3 watt, but it's not. I'm telling you, the speaker that's in this Sony is a better speaker. So, more than likely, what's going to happen is I'm going to remove the test oscillator from this and install it into here. And if I decide at some point, oh gee, I really like this one, it has so much character, I can always build another board and put it in there. But the challenge with this build is going to be that on the inside there isn't much room, and there's all these rails and stuff you'll have to hack out. So it's a game of staring at it, looking at it, double checking, measure 3 times, cut once. And like, where would I even put like stuff like a toggle switch? You've got to kind of look on the inside. This is where a technique where we have what's called a pokey tool, which is like a dental pick, and I will heat that up. And you could just use a needle or a coat hanger. Like if you have a propane torch, you can heat up a coat hanger, and then you can look on the inside and carefully go in with that hot coat hanger and melt through. Right in between the 2 rails that stick out, you melt the hole through there, and then you take your drill bit and clean that out, and then you'll know when you go to mount that switch, it'll sit where you wanted it to, from looking at it from the inside rather than the outside. So that's the game that I'm going to be playing tomorrow when I assemble this. I'm going to need to locate the petey tool. I've got the amp circuit from this old doggy amp. This had a crappy speaker. I think there was a fuzz circuit. I had a line out for a better speaker, and it's got a underneath here is an amplifier built on a PCB, a Vero, which is I JB welded this in here. The amplifier will come right out. But yeah, it's what's known as a punch amp. It's a 1 watt chip amp with a TPA 7052A chip, which is like a 1 watt low voltage, low wattage little chip amp. You can build these on perf board or Vero strip board. They're super low parts count. It's just a couple of parts on the chip and then a volume pot, and they work. They sound really good, I think. This particular one has a JFET front end. It's got a J201, like a Tillman buffer. So basically, this amp is designed for a preamp signal. It's designed for a, I want to say Walkman, an MP3 player, an iPod. That's what this is designed for. And it's a really cute thing, I gotta say, but this other design with having a switchable input, I could easily modify this, but it's not performing quite right, and something about the way this looked Like it has one kind of and then this is just like, here's a little guy, you know. So that's what I'm going to be working on tomorrow. These types of projects for me are the funnest. Whenever I can build a little contraption like that to help me do my job, where I know, well, while I'm done with this, I'm just going to be sticking these white, you know, the input, stick it into the port, the spring-loaded port, and same with the output, same with the 9-volt, and then hit the power and you're off to the races. And oh, well, at this point I really want to plug my guitar in. Well, don't fret, because there's a 1/4-inch jack on a toggle switch for you right there. So this should be a fun one. I'm looking, more than likely this will be something I will start in the afternoon and finish in the late evening. But considering the circuits are already built, it might take a lot less than I thought. Typically with these type of builds, I really take my time before that whole measure 3 times, cut once. So that's what I'm going to be up to. And I should demo it for you guys. I've got the Demeter fat control, which I'm going to be boxing up. So I hope you enjoyed the video, and I hope you'll come back to see it tested. And if you ever want something like this, I don't know why anyone would want something like that, but if you ever have any questions or comments, you can get a hold of me, and I'd be more than happy to help you out or build one for you. Okay, you guys, take care of yourselves, and peace.